To solve the problems of motion under gravity, we have to use the equations of motion. We have three equations, that is V is equal to U plus AT, V square minus U square is equal to 2AS, then S is equal to UT plus half AT square, where V is equal to final velocity, then we have U, this, that is initial velocity, then A is acceleration, then S is displacement, or we can call it as distance or height, depending on the condition. Then where T is time. So units usually velocity will take meter per second, that is final velocity, initial velocity also meter per second, acceleration meter per second square, then distance we will take in meters, time in seconds. So if I come to the motion under gravity, so we have two conditions. One, when stone or when object thrown upward, that is the first condition. Second one, when object thrown downward. We can call it as thrown, or object is moving upward, or when object is moving downward. So when object is throwing upward or moving upward, so that time we will take A is equal to negative, that is acceleration is negative. In motion under gravity we will denote A as G, so that is we can take minus G. When object is thrown downward, A is positive, so I will take A is equal to plus G. So same way, instead of S we will call it as height, that is instead of S I can use H. Here also instead of S I can use H. So now three equations will be V is equal to U minus, instead of A, minus G, that is minus GT, then V square minus U square is equal to minus 2 into G into S. Then we have S is equal to UT minus half GT square. Same way here on other side, when object is thrown downward, A is equal to, or acceleration is positive, then we have V is equal to, that is these three equations, V is equal to U plus GT. So here one mistake I made, that should be H. Here also it should be H. So V is equal to U plus GT, V square minus U square. is equal to 2 into g into h. Then we have s is equal to ut plus half gt square. These are the 6 equations depending on the condition. Actually 3 equations. Depending on the condition we have to take positive g or negative g. If the object is moving downward, we have to take positive g. If the object is moving upward, we have to take negative g. So let us see the first problem. I will take the first problem here. So we have our first problem, that is a stone is thrown upward with velocity of 40 meter per second. Determine the time required when it is at a height of 10 meter. So first I will write the given data, that is thrown with a velocity of 40 meter per second. So that is initial velocity 40 meter per second. Then the given height, that is 10 meter. So we have to calculate the time, at what time it is at a height of 10 meter. So if I thrown one object at a velocity of 40 meter per second against the gravity, at what time it will be at a height of 10 meter. So here we have the equation, that is, so I can go for this equation. So thrown is thrown upward, so g is negative, so I will use this equation. H is equal to ut minus gt square. So if I substitute the values, where h is equal to 10 meter is equal to u is 40, we have t that we have to calculate, minus half into, where g is 9.81 meter per second, that is 9.81 into, that is t square. So this is quadratic equation. So if I solve this equation, I will bring these things to the left side, that is half into 9.81 into t square minus 40t plus 10 is equal to 0. So we will get two answers, that is t is equal to 7.905 seconds, then one more, t is equal to 0.258 seconds. We are getting two values because if I consider ground surface, if I throw one object upward, it will reach some values or some height, then it will come back to the ground. So suppose maybe this is the 10 meter height, so it will reach two times it will reach the height of 10 meter. So initially at 2.58 seconds it will reach 10 meter height, then it will travel like this, then it will come back. So it will take this much time, that is 7.905 seconds to reach the 10 meter height again. So very simple problem by using simple equations of motion. So thanks for watching. Do subscribe to this channel.